In this video, I'll do some applications of limits. The first one is limit of the radius of a cylinder. It states a right circular cylinder with a height of 10 centimeter and surface area of s centimeter square has a radius given by this equation. We have to find limit s approaches to 0 positive r of s. So let's start. Now what we are given, a right circular cylinder with the height of 10 centimeter. Now here the height is constant, 10 centimeter, and the surface area of s centimeter square, which is a variable, and the radius is given by this equation. Let's see. First I'll make a right circular cylinder. Its height is 10 centimeter given, and the surface area is s centimeter square. Now what is the surface area? The top part, the bottom part, and this whole circular part, the kind of can. This is s, and the radius is given by r. Now here we have to find the limit where s is approaching to 0 positive. Now the surface area cannot be negative, and here the limit s is approaching to 0. That means the surface area is getting very small. So let me try again. Now if this is the surface area, now because height is 10 centimeter constant, so it will stay same even if the surface area is getting smaller. Now here we see, if the surface area is getting smaller, the radius is also getting smaller. Let's do it analytically. We have to find limit s approaching to 0 positive r of s, which is equal to limit s approaches to 0 positive 1 by 2 root 100 plus 2s by pi minus 10. Now the limit is given by s approaches to 0 positive. I'll change this limit into a normal limit by putting s is equal to 0 plus some variable h. Now here s is approaching to 0 positive. That means the value of s is slightly more than 0. So what I can take, s is equal to 0 plus something. Now this h is also approaching to 0, but h is positive, because if h is negative, the value of s will become negative. So if s is equal to 0 plus h, then h is approaching to 0 and h is positive. So it will become h is approaching to 0, 1 by 2 root 100 plus 2 h by pi minus 10, because s is equal to h. Now if I solve this limit by direct substitution, I get 1 by 2 root 100 plus 0 minus 10 is equal to 1 by 2 root 100 minus 10 minus 10, which is equal to 0. Here I see, if s, that is the surface area, is approaching to 0 positive, then the radius is also approaching to 0. That means if the surface area is getting smaller and smaller, then the radius is also getting smaller and smaller. Now the next application is Heaviside function, which is defined as h of x is equal to 0 when x is less than 0 and it's 1 when x is greater than or equal to 0. Now we have to sketch a graph of h on the interval, closed interval -1 to 1. So let's draw the graph. This is x-axis, this is y-axis, and we'll draw the graph of h of x. Here is -1, here is 1. Now h of x is 0 when x is less than 0. That means from this point to this point, not on 0 when x is less than 0. So I'll make the line bold. When x is less than 0, h of x is 0. And now when x is greater than or equal to 0, that means from this point to 1, because we have to sketch the graph on the interval -1 to 1. Now when x is equal to 0 and greater than 0, h of x is 1. Here is 1, so it is at 0 also it's 1, and at this point also it's 1. I'll bold this line also and this point also. Now this is the graph of h of x in closed interval -1 to 1. Now next part, B. We have to find the limit x approaches to 0 h of x if it exists. So to find that, first I will have to find the left side limit of h of x. That means x approaches to 0 negative. That means when x is very close to 0 but when x is negative. Then the value of h of x is 0, and the right hand limit, that means when x is approaching to 0 positive, then h of x is 1. Here x is greater than 0. Now we see the left hand limit and the right hand limit, both are not equal. So that means limit x approaches to 0, h of x does not exist. The next application is snowboard rental, which states, suppose the rental cost for a snowboard is $5 for the first day or any part of the day plus $1 for each additional day or any part of a day. So what we have to do is graph the function c equals to f of t that gives the cost of renting a snowboard for t days when t is from 0 to 5. So let's get started. First I'll make the graph. T, C. Now t is from 0 to 5. 1, 2, 5. C is the cost of renting a snowboard for t days. Now C is cost of renting a snowboard, and T is number of days. Now, first of all, when T is 0, then the cost will also be 0. Now, when T is more than 0, up to when it's 1, that means for the first day or for any part of the day, any part of the first day, the cost will be $5. That means this one. At 0, the value is 0, but when T is more than 0 till 1, the value of C or f of T is 5. Next, now when T is more than 1 and when T is less than or equal to 2, that means the second day, then the cost is 5 plus 1, that means 6. Now when T is more than 2, then the cost will be 6 plus 1, that is 7. When T is more than 3, then the cost will be 8. If it is more than 4 and less than or equal to 5. Then the cost is 8 plus 1, that is 9. Now this is the graph of function f of t. Now we have to evaluate limit t approaches to 2.9 f of t. Okay, this was part A. Now B. Limit t approaches to 2.9 f of t. Now where is 2.9? Here somewhere. When t is 2.9, f of t is 7. Next is limit t approaches to 3 negative f of t. T approaches to t negative, that means t is slightly less than 3. Again here only somewhere, that means the limit is 7 here. Next part, limit t approaches to 3 plus f of t, that means when t is slightly more than 3, that here somewhere, then f of t is 8. So this is how we find the limits from the graph.